Welcome viewers, in this video we will see the details about ring counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic ring counter. Counter is a digital device that is used for counting purpose from 0 to n or n to 0. It is made up of flip-flop. Flip-flop is the storage element. It will store one bit of data. It is called as a ring counter. Ring counter means it starts from 0 to n. Again it goes to 0. Like a ring, the counting is in the ring form. 0 to n and n to 0, like that it goes. Now we'll see the detail. A ring counter is a special type of application of the serial in, serial out shift registers. It is very similar to the serial in, serial out shift register. That is, data are passing serially and data are taken out also serially. The only difference between the shift register and ring counter is that last flip-flop outcome is taken as the output in the shift register. There are n number of flip-flop available, mean last flip-flop output is outcome is the output. But in the ring counter, the outcome is passed to the first flip-flop. Because of ring, the output of the last flip-flop is given as a input to the first flip-flop, so that the ring will be formed. All the remaining things in the ring counter is same as the shift register, right? So the last flip-flop output is connected as a input to the first flip-flop, so that we got the ring format. I will see the other details. In ring counter, the number of states in the ring equal to number of flip-flop. Here we are going to use the 4-bit ring counter, so we need 4 number of flip-flop. Below is the block diagram of 4-bit ring counter. There are 4 D-type flip-flops. We are using D-type flip-flop. The same clock pulse is passed to the clock input of all the flip-flop, so that it is a synchronous counter. Asynchronous means flip-flop, the clock pulse given to only first flip-flop. Remaining will get from the previous. But here clock pulse given to all the flip-flops, so it is synchronous, right? So we are going to use 4-bit ring counter. We are using the 4 number of D flip-flop, same clock pulse given to all the flip-flops, so it is coming under synchronous counter, right? In order to obtain the ring, we are using overriding input, ORI, that is used in the design of the circuit. This ORI, overriding input, is used as a clear as well as preset. It can be used to clear. Clear means it will make the output 0. Preset means it will make the output as 1. Preset, set means 1. Clear means 0. Now we'll see the logic diagram. So this is the 4-bit ring counter made up of 4 flip-flop. 1, 2, 3, 4. D-type. What is the nature of the D-type? The input what we are giving, that will be reflected at the output, whatever may be the previous state. Whatever may be the previous state, the next state is follows the input. If the D is 0, Q also 0. D is 1, Q also 1. That is the nature of D flip-flop. What input we are giving, that will be reflected in the output. What is the previous state, it will not bother. So that the data what we are passing will be reflected at the Q0. Right, that is the nature of flip-flop. So the clock pulse is given to all the flip-flops, all the 4 flops, same clock pulse simultaneously given. So it acts as a synchronous counter. Now we have ORI, overriding input, is given to preset for the first flip-flop, inverting. So it will preset means it will set the Q0 as 1. Q0 output is 1. Preset means set the value is 1. The same ORI is given as clear input to the remaining 3 flip-flops, so that it will clear the output. That is, it will make the output as 0. So ORI given as preset for first flip-flop, that make the set that will set the output as 1. The same ORI is given as a clear input to the remaining 3 flip-flops, so it will clear the output, that is output is 0. Now we'll see how it will perform the ring operation. The output is 1 when the preset is set to 0. The output is 0 when clear is set to 0. we already discussed. Same ORI is given to preset for the first flip-flop, so it will set the output as 1. The same ORI is given as a clear input, so that it will clear the output, so output is 0. Both PR and clock always work on 0 because they are all active low signal, inverted signal we are giving. So this is the important thing. Preset 0 means preset. Set means it will set the output 1. Clear 0 means it will clear the output, so 0. Right? Preset, set the value as 1. Clear the output 0. These two values are independent with the D input and the clock pulse. There is no relation between these two. Now we'll see how it will working of this ring counter. So the working, we'll see the ORI input is passed to the preset input of the first flip-flop. So it also passed to the clear input of the remaining 3 flip-flop. So what happened? The preset input set to 0 for the first flip-flop, so that the output of the first flip-flop is 1 because it is inverted, so it is 1. And the output of the remaining flip-flops are 0. We already discussed. Preset means it set the output as 1. Clear means it set the output as 0. The output of first flip-flop is used to form the ring in the ring counter. So we got 1 in the first flip-flop. For using the preset, we are getting 1. This 1 is used for ring purpose, for ring counter, in order to form the ring counter. This 1 is passed 1 by 1. We already discussed it is a serial in, serial out shift register. So the 1 what we are got from the preset is passed 1 by 1, so that we got the ring format. See this is the ORI signal, overriding input, clock, then 4 outputs, Q0, Q1, Q2 and Q3. Right. First ORI signal is low, clock, whatever may be the clock pulse. Whatever may be the clock pulse, the Q0 is set to 1, remaining flip-flops are 0. We already discussed. Preset means it set the output 1, clear means it cleared the output as 0. So it is in lower condition, whatever may be the clock pulse. These highlighted ones are preset values. By giving the next clock pulse 1 by 1, these ones are formed, that is passed to the next stages, so that it is going in a ring order. Right? These shaders are nothing but by making preset 1. While making preset 1, it 1. For the next 4 clock pulse, this one is passed to the, because it is a shift in, shift out, serial in, serial out register. So the in output of first flip-flop is passed to the next flip-flop. This 0 is passed, this 0 is passed to next. So that we got 0, 1, 0, 0. In the next clock pulse, this one is passed to third flip-flop. So that we got 0, 0, 1, 0. In the fourth clock pulse, this one is passed to fourth flip-flop. So that we got 0, 0, 0, 1. In the next clock pulse, this one is passed to first flip-flop, because the fourth flip-flop is connected to the first flip. That is a ring. So that we are getting again first flip-flop input as 1, 1, 0, 0, 0. See, we start from 1, 0, 0, 0. In the sequence pulse, the 1 is moving to the next stages. Again it become 1, 0, 0. So this is a ring format. So while passing every clock signal, the 1 is moving. Finally it goes to the beginning, the first flip-flop, right? So that we got this, right? So we see the remaining detail. The preset 1 is generated. What are the stages available? ORI input is set to low and the clock signal does not care. This ORI should be low and clock signal should not be there. Then only the preset is 1. Another case, when ORI input is set to high and the low clock pulse signal is passed as a negative clock edged trigger. Another possibility is ORI should be high and clock pulse should be low. At the time also preset will be available, right? The preset available, first condition, ORI is low, no clock signal, it will set the output as 1. If it is high, there should be a low clock pulse, negative edge triggered clock pulse. At the time also the preset value 1 available, these two cases. The ring forms when the preset 1 is shifted to the next flip-flop at each clock pulse. How we are forming the clock? How we are forming the ring? While passing the clock pulse is keep on moving to next flip-flop. So that we have got the ring format. Again it goes to the first flip-flop. So in this video we discuss ring counter. How we are forming the ring counter, which is very similar to serial in, serial out shift register. The last flip-flop output is given as a first flip-flop input. So that we have got the ring format. We have ORI, overriding input. That is act as a preset for first flip-flop. So the set the output as 1. Clear for remaining flip-flop, that is 0. So when the ORI signal is given, it will make the output as 1. By consecutive clock pulse, the 1 is passed to the next flip-flop. So that we are forming the ring. Finally, the last flip-flop output 1 is passed to the first one. So that we are forming the ring format. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.